Welcome back to our continuing series where we'll go through 5 SAT math problems a day. Again, please attempt the math problem, pause the video when it shows up, then unpause it and I'll show you some ways to solve them. So starting off, we have this equation, h equals 3a plus 28.6, and a pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? And I notice, as a math teacher, this looks like slope-intercept form. This looks like the similar equation, y equals 3x plus 28.6, and in this y equals mx plus b form, I know this 3 is the slope, I know this 28.6 is the y-intercept, and the rate of change is the slope. So I would expect that the rate of increase would be 3. Now, I could also, if I'm unsure about this, actually make a table and see it happening. So this works for ages 2 to 5. So let's have age. Age does not start with a G. Let's try this again. Age. Let's have height. And from 2 to 5, so we're going to consider years 2, 3, 4, and 5. So at year 2, I would do 3 times 2 plus 28.6. 3 times 2 is 6, plus 28.6 is 34.6. At age 3, I would substitute the 3 into my equation. And doing that work, 3 times 3 is 9, plus 28.6 is 34. Not 34, 37.6. And similarly, when I put in 4, I will get 40.6. And when I put in 5, I'll get 43.6. And you can see each year, the estimated increase, let me change colors here, is a positive 3. You can see 34.6 to 37.6 to 40.6 to 43.6. Okay. Give this one a shot. All right, this one looks like sort of a beast of a problem, but it's actually not too bad. So the formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following over here gives P in terms of M, R, and N? So basically what this is saying is, let's get P by itself. So I don't have much room to work, so I'll start up here. But I notice that in here, I have all of this divided by this term down here. So I'm going to multiply the right-hand side and left-hand side by this denominator. So I would have 1 plus r over 1,200 minus 1, and do that on both sides. And so now I have 1 plus r over 1,200 minus 1 times my m. And that will equal all of this left over times p. So r over 1,200, 1 plus r over 1,200 to the n times p. And I still need to get p by itself. Notice I have things multiplied to the p, so I will just go through and divide everything by this mess. So divide by r over 1,200 times 1 plus r over 1,200 to the n. Do that to both sides. And let's see. This cancels, and now I'm just sort of looking for p equal to this. So let's see. R, nope, not right. Not. Wait a second, this looks, ooh, I forgot something. Let me go back and fix that. This should be to the nth power because of this n right here. Might put that in. Let's see. We have that, we have that, we have that. Looks like my answer is B. All right, give this one a shot. Okay, so in here, these problems can be a little bit frustrating. So if a over b is 2, what's the value of 4b over a? So one option is this. This is probably the option that most students would be able to latch on to best. I can treat this like a nonlinear system and use substitution to solve it. So if I take this and solve for one of the variables, I'll get a equals 2b. And then I can put that into here, replacing my a with 2b, and get 4b over 2b. The b's cancel, 4 over 2 is 2, and that gives me my answer. There's another possible way to solve this, and that is the following. So I know that a over b is 2. I want to find 4b over a. So I can actually try to make this look like that. So the first thing I'm going to do is flip both the fractions. A over b is 2 over 1. That means that b over a is 1 over 2. And notice I'm just sort of making this look more like that. So now I have the b over a. But I don't want b over a. I want 4b over a. So to finish that off, I'll just multiply both sides by 4. And on the left-hand side, I now get 4b over a. And 4 times 1/2 is just 2. Okay, give this a shot. So this problem is something that's covered quite often and pretty extensively in sort of your normal math classes. It's a system of equations. The only thing that I see here that might make it a little bit tricky is the fact that this one isn't in the correct order, whatever correct order means. So I'll rewrite this. I'll leave the 3x plus 4y in that form. But down here, I want to match up the x's and y's, so I'll have negative x plus 2y. And now I can just do elimination. The problem with solving, so this is what's happening. I want to solve for x, solve for y. The problem with solving for either one is, let's consider this. If I solve this for x, I would subtract the 4y from both sides, then divide by 3, and I would have, like, I've solved for y, great, right? But, sorry, I've solved for x. But I've solved for x in terms of y. I don't have a number here, I have another variable. And a similar problem would happen if I solved for y, I'd have an x on the other side. And the same thing happens down here. The problem is one equation, 2 variables, there's not enough information. So we'll use elimination, which is a way to get rid of one of the variables so I can solve it. I have a couple of options. I'll do this one. So I see the 3x and the negative x, and I can cancel it out by multiplying by 3. So that way I'll have a positive 3x and a negative 3x. So let me write those out. So we have this unchanged. But down here, I'll multiply everything through by 3. So I get a negative 3x, a 6y, and 3 times negative 19 will give me negative 57. 3x minus 3x cancels out. 4y plus 6y is 10y. Negative 23 minus 57 gives me negative 80. Divide both sides by 10. And lo and behold, I've actually figured out what my answer is, because there's only one where y is negative 8. But just for good measure, I'll go back and find the x value. So I'll choose either one. This second equation has generally smaller numbers, so I'll use that one. My computation might be a little bit easier. But now I know what y is, so I can put negative x plus 2 times negative 8 equals negative 19. And I can solve this now because I only have one remaining variable. The other one has been determined. So just solve this out. Minus 16 equals negative 19. Add the 16 to both sides. I get negative x equals negative 3. Divide both sides by negative 1. X equals 3. And so I have the coordinate pair 3, negative 8. Now, I'm not going to go through the whole process, but if you have time, you could actually just check all of these and say, all right, let me see if this is a solution by trying 3 times my x plus 4 times my y equals with a question mark, because I'm not sure. And in this case, negative 15 minus 8 does in fact equal negative 23. Okay, so that worked, but it would have to work for both. So I put it in here, 2 times negative 5 minus negative 2 equals, with question mark, negative 19. That would be negative 10 plus 2. That sure as heck is not negative 19, so that's how I know this is not a solution. And you could actually just check, ooh, did I mess up? I did mess up. That's y, so it should be 2 times negative 2 minus, I'm assuming, yep, negative 5. So that would be negative 4 plus 5, still not equal to negative 19. So I can do that. It's probably a little faster to just go through and do the work. But if you forget it is an equation, you can just check each one, see which one works. All right, give this a shot. Okay, so last problem for this. We have g of x equals ax squared plus 24. And for the function above, a is a constant and g of 4 is 8. What's the value of g of negative 4? Now, there are a couple of options. So I'll start off with the option that most people might go with, and that is the following. I know that in this, my x value is 4, my g value is 8, so I could actually solve the equation. 8 equals a times 4 squared plus 24. Subtract the 24 from both sides, so I would get negative 16 equals a times 16, divide both sides by 16, and I'll get negative 1 equals a. And then I can realize that, all right, so my specific form here, my actual equation will be negative 1 x squared plus 24. And when I do this and I put in negative 4, I can actually get my answer. G of negative 4 equals negative 1 times negative 4 squared plus 24. Negative 4 squared is positive 16 times negative 1 is negative 16. Negative 16 plus 24 is positive 8. Now, that took a reasonable amount of time. There's actually a much quicker way to do this, and that is the following. You need to realize this is an even function. What that means for us is, if I look at the terms, the degree of this term is 2, the degree of this term is 0. 2 and 0 are both even numbers, and so this will be symmetric about the origin, which for us just means that if this looks like this going to the right, it'll look like this going to the left. It'll be flipped over exactly. Sorry, and I said about the origin, I didn't mean that, about the y-axis. Odd functions are symmetric about the origin. Now, how is that useful? Well, if I look here, this is g of 4. That's 4 units right. And 4 units right, I have this point 8 units up. But since this is an even function and it's symmetric about the y-axis, if I know what happened 4 units right, I automatically know what happens 4 units left. The actual definition of an even function is this. A function is even if f of x is equal to f of negative x. And so without even knowing the value of a, I can say, okay, this is even. G of 4 is 8, so g of negative 4 has to also be 8. All right, I hope that helped out.